Okay, folks. So in this week for AI with Ritesh, we are going to talk few things. One is we are going to touch upon a mixture of experts. This is something a new technology. I'm sure some of you have heard of it. If not, you will get a chance to understand some of it. And Google launched their Google Gemini. So we'll briefly touch upon that. There is also a European Union has created an AI Act. So we will talk briefly, and there is something Apple is doing in the machine learning AI space, and then we'll briefly touch upon what they are up to. With that, welcome, and let's get started. So I'm sure there are many things you have heard recently about things happening in the AI space, and we are in what? Almost mid-December here. Almost the year is about to get over. But the AI is not stopping. There are so many developments happening within the AI space. And one I would like to highlight today is around what we call a new kid on the block. A Mistral, it's a company which I think got launched in the March of this year. So it's not even a total 9 months. So maybe it's a 9 month, a baby just got born. And they had launched a 7 billion parameter model a few weeks ago. And they extended that model with what we call a mixture of experts. So there are like 7 billion parameter model into a single model. This is like similar to what GPT-4 does. GPT-4 has, and then there are many unknowns about what GPT-4 has, but there are few things what people have been talking about what GPT-4 has, right? So somebody had inadvertently mentioned that okay, GPT-4 has 8 times 220 billion parameter model. I don't know whether it's true, false, but this is out in the public and people are talking about it. But in a way, it's using what we call, from a science point of view, a mixture of technology. So what we are doing as a part of here is understanding what this mixture of experts, sorry, not technology, mixture of expert, MOE, as a technique. Let's get started. So what is the MOE, or a mixture of experts? So there are many things have been done from an LLM optimizations point of view. People are using a fine-tuning techniques called RLHF or LoRa or parameter efficient fine-tuning. But here, when you are building a model, as a part of that, you are creating a different set of a model or an expert models. So what Mistral did in this scenario, they created 8 different expert model of a 7 billion each, and they are creating a single holistic single model, what they known as, or they named it as a Mixtral, 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 right? Let's come to what that is, how that mixture of expert would work. So if we think from a traditional machine learning point of view, in traditional neural network, there is, let's say, an example of a feed-forward neural network. And if you don't know about feed-forward neural network, that's okay. All you need to know it's not current. It's a traditional way of doing a neural net. And when a data or input has been given to that particular model, it passes through all the layers within that neural network. And then it gives you output. That means the output, there is a latency between input and output. What MOE, or mixture of expert, is solving is it's based on the task on the input. Let's say we want to do a summary. And in that scenario, there is a brain, a single brain, which will identify that, okay, where the summarization model, which model out of this 8 model are expert in summarization, and it will send that task to that particular model. If we ask a model to do a translation, for example, and it will find which model is expert in translation, and it will route a request to that particular model. So you may wonder, hey, this is confusing. Can you use some simple analogy? So yeah, let me take an example, right? So here I have a cousin. He's a doctor. And he's a very good doctor, but he's a general practitioner. And when I say general practitioner, he's not expert in any particular domain. He's not a heart specialist or a brain specialist, but he's a general practitioner. And when somebody goes to his dispensary, he owns his own independent practice. And somebody, when they go to, he literally asks questions. Okay, what about this? What about this? And then based on that, he diagnose and then he treat the individuals on a particular symptoms. But now if we take this analogy of a doctor and let's say we want to create a multi-specialty hospital. Now in this multi-specialty hospital, what we want to do is we want to have a expert surgeons. One surgeon is specialized in neuroscience or neurology. The other surgeon might be specialized in cardiac surgery. The other specialist is in oncology and so forth. And we want to operate this multi-specialty hospital. How in this scenario compared to the mixture of expert? Similar to our specialist doctor, we have an expert model in the gigantic a single model. There are 8 different models, which are 8 specialist model in a way. And there is a thing called router, which is kind of making a decision of where to send this particular input. So in this scenario, when I spoke about my cousin, for example, he's a general practitioner and he is very good at diagnosing, and based on the diagnosis, he is able to refer this patient to, maybe you need to go to a heart surgeon, maybe you need to go to an orthopedic, and then so forth. So maybe that cousin is sitting here as a router in the inquiry state, maybe as a part of administrative office, and he is routing that patient. So any new patient come to the hospital, he does the initial diagnosis, and based on that, he's sending that patient to either neurology department or either oncology department and so forth. Similarly, that router is making that decision. So here is a diagram of how in conceptually this would work. So let's say you have an input and the first input is going to the router. Router is making a decision that, hey, this is meant for expert number 3. And the expert number 3 is taking it and doing whatever the expert model it does. Maybe it's a translation from English to Spanish. It does the translation and send the output to the next layer. Similarly, let's say somebody came and say, okay, I need to do a summary. I don't need a translation. In that scenario, the router says, okay, well, in this case, the model number 6 is an expert in summary. Let me send that request or route that request over to model number 6. And then model generates the output and boom, we got an output. So that is in a nutshell when we say mixture of experts from a model concept point of view. Now, similar technique exists in GPT-4 as well. GPT-4, as we know now, has 8 different model underneath it. And then based on a task, it's making a decision. Should we route it here? Should we route it here? Should we route it here? Right? So then the question you may have is, why not everyone is building the mixture of experts? Well, there are a few things. It's like, why not everyone is building a multi-specialty hospital? Resources. Not everyone has the resources. Maybe in this scenario, to train such a large model, you need a lot of GPU, you need a lot of time. Also, is there a demand for so many specialist models? Maybe there is. Everyone is looking for GPT-4. So maybe I'm hoping more companies would go and build such models for MOE. But at the same time, not everyone can build it because it is very complex. And to build such a model, it requires a lot of brain power, a lot of human power, along with the compute power. So not everyone can build it, and hats off to the Mistral team who were able to build it and release it as an open model, as an open access Apache 2.0 license model. That means anybody can take that model, rip it apart and build of their own, right? So there we go. A lot of creativity should happen now since that MOE models are out in the open access way. But then the question comes down to is, okay, if everyone will build it and if I use it, what are the situations when I should not use it? Or where should I use it? First of all, let's start with that. So the first use case would be of if you have a very large and a diverse data set, then it makes sense to use MOE. If you need a specialization, while generic model would not work for you, then you need a specialization, and then this is where MOE would be more applicable. Assuming you have enough compute resources to support it, it requires a lot of GPU to begin with. It also has a lot of scalability requirement because you need to scale up from where it is to where you want to go. And if you are looking for a state-of-the-art performance, is certainly where MOE would work well. But then the question is, where should I not use it? Why should I always use it, and then in which condition I should not use it? So it comes down to your data set. If you have a very small data set, or the data set is homogeneous, which is kind of a similar pattern, then it wouldn't make sense to use the MOE. The amount of time it takes to either train or tune the model may not make sense for you to justify if your data is kind of in a homogeneous state. If you don't have a compute resources, it makes sense. Also, if you want a simplicity, because maintaining such a large model, it's going to take a while. So if you are not looking to maintain such a model, then probably it doesn't make sense for you to operate such a large model. If you are looking for rapid development, then this MOE model would not make sense, at least in current state. This may change in coming months, who knows? But at least in current state, it takes a lot of time, a lot of effort, and a lot of resources to create such a model. So rapid development deployment is something out of question at this point. And of course, if you don't have a subject matter expert, you should not approach this. But then, now we are sort of done with MOE as a whole. What else is trending this week or in last few days? Google Gemini, they showcased a wonderful video. It's actually a viral video. If you haven't got a chance, I would highly suggest you get onto this hands-on Gemini video and go through what exactly they are doing. This is, again, there are some questions. People are questioning that how this video was created, because actually there is no such modality of a video exist. So maybe it's a combination of not just video, maybe they had, and this blog actually explains how detailed it was done, or how that interaction with Gemini was done. It's primarily using the image and feeding the text prompt is how they're describing. And this is how they created that multi-model prompting with Gemini. But if we see what's in that video, and if the amount of benchmark what Google has showed up, which is comparing with GPT-4 model, this is mind-boggling in a way. It's literally beating on many of the benchmark on what GPT-4 can do. And if we are able to combine this multimodality, this is amazing, right? So let's hope what they have developed is actually a real thing, if not coming in few weeks to few months as a real thing, and then we should see how actually it's panning out. So that's on the Gemini. European Union. Yes, the same union who has a GDPR for your email addresses. There are many European Union acts, and then they have come up with another act for AI on how companies should operate AI. And then particularly in this scenario, European Union is looking for the safety and the security of their citizens, and it makes total sense in a way where they are giving importance in two aspects. If you look at the first, they are saying it's the overall EU as a union is working all together and working to solve the governance. And second, it's balancing the innovation but also safeguarding the fundamental rights and the public welfare, which is what government should do, and which is where they are excelling when they have developed this European AI Act. I'll do another video at later time in terms of going through the line by line of what actually the act is and how it impact for a company, for an individual, and whatnot. But this is a very good step in terms of coming up with an AI Act for a large body of countries, an entire European Union. And the last thing for today is more about Apple. Now, we have seen a lot of things from Google, from certainly Microsoft with OpenAI, with Amazon, and now Apple is gearing up for AI. And what they have released is they have released their framework they call MLX. And particularly, this framework is used for building LLM based applications. So, this framework supports Stable Diffusion as an image generation model. It supports Llama from Meta for text generation, text extraction, and many of the text NLP work. And this MLX framework actually works with Apple Silicon. That means this entire framework, you can use it on Apple Silicon like M1, M2 Mac and many other product what they sell from a MacBook or MacBook Pro point of view, and allow developers to build applications for the silicon chips using this open source framework. So this is a very good step if you ask me from a Apple point of view, where they are at least open sourcing many things and allowing the developer community to build applications. Maybe this is a first step towards getting that adoption of AI at the edge, right? Who knows? Maybe next time they will have a framework for iPhone or iPad or something else altogether. So that's all we can hope. But with that, I thank you for your time for watching this, and feel free to use comment for any questions you may have, or what else I can come up with from a video point of view. Thank you for your time.